Hello everyone, welcome back to even digital class. So, in today class we will discuss a new concept, that is our pipelining. And before going to the concept of pipelining, let me give an example that when we want to do some job by using a single person, then it will take multiple times, but when we will do the same job by using multiple peoples, then we can perform that job in less time as compared to the previous. That means the job is divided into different parts and each part is assigned to different persons and each person is working on that part of the job simultaneously, or you can say parallelly. So, that means we are following a technique in the computer organization when we will execute multiple instructions in some less amount of time. So, that technique is called as our pipelining. So, pipeline is widely used in modern processors and it is basically used, or you can say this technique is used to improve the system performance, and the performance is measured in terms of throughput, and that means number of works done at a given point of time. In other words, you can say that a computer system can execute multiple instructions at a single point of time by using this technique, and then pipeline organization requires sophisticated compilation techniques. Okay. So, we will discuss about these pipeline techniques and what are the hazards we are facing, or what are the problems basically we are facing, and what are the solutions to that will be discussed in this chapter. So, next let us go to the basic concept of the pipelining. So, first concept is that somebody wants to execute the program faster, or when we are choosing a computer system, at that point of time we were discussing about the speed of the computer system. Okay. Then how we will get a faster system, and that concept is used by involving a faster circuit technology to build the processor and the main memory. That means there must be a circuit which is used or which executes the programs by establishing the connection between the processor and the main memory, because we have to fetch or you can say we have to read or write any type of data either from the main memory or to the main memory. Okay, and that is done by the processor, because every instruction is executed by using the processor concept. Then arrange the hardware so that more than one operations can be performed at the same time. Okay. So, there are different components included in the processor and also in the main memory. So, we have to arrange that hardware, or you can say that circuitries in such a way that more than one operations can be performed at a single point of time, or you can say more number of operations can be performed parallelly. Then in the latter way, the number of operations performed per second is increased even though the elapsed time need to perform any one operation is not changed. That means by using this technique, the number of operations is increased. That means we can perform more number of operations within a minimum unit of time, but the elapsed time of the operations is not changed, or it is same for all the operations, but the number of operations is increased. Okay. And then let us go to the concept or the definition of the pipeline. So, pipeline is a technique of decomposing a sequential process into sub operations, with each sub operation completed in dedicated segment. So, by using this technique, which is called as a pipeline, when the operation is done by using much more time, so that operation is divided into number of operations, and that is called as a sub operation, and that sub operation has to be completed in a specific time period. And then pipeline is also sometimes called as assembly line operations. Okay. And then next, it is similar like assembly line of car manufacturing, like for example, when we are developing a model of the car, then in the first station in an assembly line set ups the chassis or the engine part, and the next station is installing the engine, and then another group of workers fitting the body. So, there are, let the operation is our manufacturing a car, but that operation is divided into multiple sub operations like set up a chassis and installing the engine and then fitting the body. And when one car is in this stage and when that car is going to this stage, then another new car can be given into this group of peoples. Okay. So, this is the concept of using the pipelining techniques, and then let us see one traditional pipelining concept. Okay. So, here is the example of a laundry. That means the operation is our, we have to wash the clothes and also we have to dry it and also fold. So, there are 4 persons and it is named as Anne, Brian and Kathy and Dept. So, they have one load of clothes to do these following operations, and the person who washes the clothes, it will take 30 minutes, and for the dryer it will take 40 minutes, and then for the folding operation it will take 20 minutes. And if we will perform these operations in a sequential manner, then it will take approximately 1.5 hour. Okay. Then here you can see the sequential laundry takes 6 hours for 4 loads. As I have told you that to wash, dry and fold for a single clothes, it will take 1.5 hour, and so in this way the 4 persons can have their clothes in 6 hours if we will perform that in sequential manner. Okay. And here you can see the washer and dryer and folding, and then after folding then another cloth is entered and then it will go for washing, then drying, then folding. So, like this it will take up to 6 hours for 4 loads. If they learn pipeline, then how long the laundry will take, we will see in our next slide. So, if it will follow the pipeline technique, then that laundry will take 3.5 hours for 4 loads, where without using the pipelining concept, the laundry will take 6 hours. So, the time period is same, okay, and the amount of job is given is also same, but the time of completion of the job is different in the pipeline technique and non-pipeline technique. So, here you can see the task order is also same, first it will go for A, then B, then C, then D. So, when A's clothes is in the washing phase, then it will go for drying, then when the clothes of A will be in the drying phase, then B clothes can be entered into its washing phase, and then when the B cloth into the drying phase, then C clothes can be entered into the washing phase. That means it is not dependent on each other. That means here is not the single person who are doing the washing operation also doing the drying operation. Okay. So, this here you can see some clothes of A is in the folding phase and the clothes of B in the drying phase and the clothes of C in the washing phase. That means in this single time period we can do multiple operations. So, this is the concept of pipeline, and then pipeline does not help latency of single task, it helps throughput of entire workload. That means when we are using pipeline, that does not only decrease the execution time of the job itself, but it decreases the completely workload's execution time, because here the washing and drying and the folding, it will take 1.5 hour for every load, but that time is not different when we are using the pipelining concept. But when we are doing these operations for multiple, then this the time will be different. Okay. So, here for single task the time will be same, but the entire workload, here the 4 loads are given. So, the execution of the 4 loads, it decreases to 3.5 hours. Okay. But for a single load, the time is same, that is our 1.5 hours. Then pipeline rate limited by slowest pipeline stage. So, how we will calculate the rate of the pipeline? By including the pipeline stage which is slowest, and then multiple tasks operating simultaneously using different resources. So, here you can see multiple tasks are performed. Here is the folding operation, here is the drying, and here is the washing operations. They are performed simultaneously using different resources. Here, as I have told you that the person are not same who are doing these operations, they are different. So, we are using different resources, but the operations are also different, but they are doing in the simultaneous way. And then potential speed up is equals to number of pipeline stages. So, how will the performance will be increment? By incrementing the stages of the pipeline, whether it is 3 stages, 5 stages, 7 stages, like this. Then unbalanced lengths of pipe stages reduces the speed up. Then time to fill pipeline and time to drain it reduces also the speed up. Then it stalls for the dependencies. When one job is dependent on another job, then the pipeline will be stalled, or you can say it will be idle for some period of time. Okay. If the drying operation of one cloth or one load is depend on the washing of another load, then if we cannot perform this in a simultaneous way. Okay. So, we have to wait until this drying operation is complete, so that we can start another operation. So, in that situation, the task or the processes which is given or the instructions, that execution has to be paused until the dependent process will be executed. Then, what is the idea of pipelining in the computer system? That is in the traditional concept. So, let us implement in a computer environment that the processor execute the program by fetching and executing instructions one after the another. That means, when the processor executes the program by instruction, that means it will fetch that instruction from the main memory and then it executes by using different components in the processor, and that is performed in a sequential way. Let Fi and Ei refer to the fetch and execution steps for the instructions, and here is our Ii, that means our instruction, and Fi stands for fetching of ith number of instruction, and Ei stands for execution of ith number of instruction, and here is the ith number of instruction is our denoted by Ii. Then here is the implementation. So, when the execution of here is our 3 instructions I1, I2 and I3, and we are using 2 phases, one is fetch and execution. Then if we will follow the sequential execution, then after completion of one instruction, then the processor will start to fetch one instruction, then it will execute, then after that it will fetch another instruction, and then it will going for the execution of that instruction. That means after completion of one instruction, the processor can go for another instruction, and that is done by, here you can see there is one instruction fetch unit and there is the interstage buffer, and here is our execution unit. That means instruction fetch unit will fetch the instruction from the main memory, and that will be placed for some period of time if the execution unit is busy in the buffer, and then it will go for execution unit when it is free, and then the execution will be takes place. And here is the pipeline execution, and in the pipeline execution here you can see that the 1, 2 and 3, here we are executing also the 3 number of instructions, and in the first cycle, and here you can see the pipeline technique is controlled by a clock signal, and the stages are divided in such a way that each stage is completed in one clock cycle, or you can say it is measured by using the clock cycle periods. And here the fetching of the instruction 1 will be completed in the clock cycle 1, and then execution of the instruction 1 will be completed in clock cycle 2. And when the instruction 1 is in the execution fetch, then at the same time the processor can fetch another instruction and it will load that in the buffer, because the execution unit is busy with executing the instruction I1 in the clock period of 2. That means in the second clock cycle, I1 is the execution fetch and I2 is the fetch phase. Then after in the clock cycle 3, the execution of I1 is completed, that means the execution unit is free now. So that the instruction 2 is in the buffer, so it will be loaded in this execution unit, then it will be executed in this third clock cycle. And when that is going for the execution unit, at that point of time the processor will fetch another instruction I3 let by using this instruction fetch unit, and it has to wait in the buffer, and then after execution of this in the fourth clock cycle let, the execution of the I2 instruction 2 is completed, so that the instruction 3 can go for the execution. Okay. Computer that has two separate hardware units, one for the fetching and another one is for executing them. Here you can see one hardware unit is doing the fetching operation and another one is of execution operation, and the instruction fetched by the fetch unit is deposited in an intermediate buffer, that is our B1. Okay. And this buffer is needed to enable the execution unit while fetch unit is fetching the next instruction. That means the instruction which is fetched by the fetch unit and it will wait for the execution, that will be stored in this intermediate buffer. Okay. And then the fetching unit can go for the another instruction. And then in the pipeline execution, the computer is controlled by a clock, and any instruction fetch and execution steps completed in one clock cycle. Here you can see the execution of instruction 1 and the fetching of instruction 2, it has to be completed in a single clock cycle. So, that is the concept of pipelining, and it is the implementation of the pipelining technique in the computer system. Then let us see another example, that where we are using 4 phases, one is fetch, decode, execution and write. In the previous we are using only 2 phases, one is fetch and execution. So, here you can see execution is divided into 4 number of steps, okay, that is our fetching operation and decoding and executing and write into the memory. And then after performing the fetch operation, there will be one intermediate buffer B1, and then it will go for the decode instruction, and after decode instruction, that the output of this stage will be stored in another buffer, and that is called as B2, and then from the B2 it will go for the execution, and then after execution the output will be stored in another buffer in the B3, and at last it will go for the write results in the memory. So, here in this type of pipelining we are using 4 stages, and here you can see in the 4th clock cycle the instruction 1 is in the write result fetch, and at the same clock cycle the instruction 2, it will be entered into the execution fetch, and in the instruction 3 it will be in the decode phase, and the instruction 4 it will be in the fetch phase. So, before this they are loaded into these buffers, okay, when these units are busy. And next concept is our, let us see what are the work of these stages. So, in the fetch stage the instruction will be read from the memory, and in the decode phase the instructions are decoded, and then the source operands will be fetched, because after decoding the whatever the source operands, maybe it is from the main memory, but fortunately we are using the cache memory. So, it may be main memory or it may be in the cache memory, we have to fetch that source operand, and then in the execution phase whatever the operation specified in that instruction, whether it is addition, subtraction, multiplication, any type of operation, that will be performed in this stage of the pipeline. And then in the write of the result stage, the result is stored in the destination location, whether it is a register or it may be a memory location. Okay. So, this is the stages of the pipeline, and where you were using 4 stages of pipelines, but in the previous we are using only 2 stages of the pipeline. Okay. So, this is all about our today class. Okay. In today class we have discussed about the basic concept of pipeline and the implementation of pipeline when we are using 2 stage and also in the 4th stage. So, in the next we will see the role of cache memory, and if you have any doubt regarding the pipeline you can mention it in the comment box. Till then keep watching. Thank you.